Hello everyone, I welcome you all to my channel Revealing Concepts. In today's class, we would be seeing two special cases using the substitution method. So the question says that in a shop, the cost of 2 pencils and 3 erasers is rupees 9 and the cost of 4 pencils and 6 erasers is rupees 18. Find the cost of each pencil and eraser. We are going to solve this story problem using substitution method. So since we are asked to find the cost of pencil and eraser, therefore these would be the two quantities which we would assign each variable as. So let x be the cost of single pencil and y be the cost of single eraser. So as per step number 1 of the story problems, we have used variables and we have assigned each variables with the quantities that we are supposed to calculate. Now let us use the given conditions to frame two equations, that is two linear equations in two variables. So the first condition says that in a shop the cost of 2 pencils and 3 erasers together is rupees 9, which means that the cost of 2 pencils would be 2x because cost of single pencil is x. Similarly, the cost of 3 erasers would be 3y and together the cost is equal to 9. This is your equation number 1. Likewise, the cost of 4 pencils and 6 erasers is rupees 18. So the equation becomes 4x plus 6y equals to 18. So this is your equation 1 and this is your equation number 2. So using the given conditions, we have framed two equations. Now, let us solve these two equations using the substitution method. So according to step 1 of the substitution method, we would be isolating the variable x and getting its value in terms of y. So consider 2x plus 3y equals to 9. Shift everything else on the other side and keep your x on the left hand side. So we get 2x equals to 9 minus 3y. X would be equal to 9 minus 3y upon 2. So we have got the value of x in terms of y. This is the end of step number 1. Now step number 2 is the step where magic of substitution happens, where our equation in two variables gets converted into equation in one variable. So step number 2 is the magical step where we are going to use equation number 2. So now you consider, or you can say substitute. You can name this as star and write star in equation 2. So write down your equation 2, which is 4x plus 6y equals to 18. Instead of x, you are going to write 9 minus 3y upon 2. Now we have to simplify the entire equation and get the value for y. So I'll cancel 2 with 4. So 2 1s are 2, 2 2s are 4. And now multiply 2 with every term inside the bracket. So 2 into 9 is 18 and 2 into 3 is 6 plus 6y equals to 18. Now here if you see, minus 6y and plus 6y both are like terms with opposite signs. That is why these two terms get cancelled and we get something of this form. 18 equals to 18. So this is the end of the solution. But now how exactly are you going to conclude this problem? Here if you see, you are not able to find the value for any variable. Your variable y gets completely cancelled out and you get something of the form 18 equals to 18. Now there would be certain equations which when solved would make you reach to this step where you would have certain numbers on both the sides of the equation. Now, if you just have numbers or numerical values on both sides of the equation and if the condition is true, which in this case is true, right? 18 is equal to your 18. So in this case, you can say that there are infinitely many solutions that are possible because whatever value you take for y, you would eventually get 18 equals to 18. And if there are infinite possibilities for the variable y, likewise there would be infinite possibilities for variable x because here if you see, your x is totally dependent on your y as per equation number star. So the main takeaway from this question is that if at all in exam you get to solve certain pair of or certain system of linear equations where eventually you're getting just numbers on both the sides of the equation, and if the resultant value that you get is true, then in that case you can say that the given system of linear equations have infinitely many solutions, because this condition is true for any values of x and y. Therefore you can say that there are infinite possibilities for values of x and y. And that is why you can say that there is no unique cost for a pencil or pen given these conditions are true. So this is how you come to the end of the conclusion. Finally, you can say that therefore there is no unique cost that could be determined for single pencil and eraser as per the given conditions. This is how the conclusion statement would look like, and you could conclude this because you got a numerical statement which was true, and that is why you said that the given system of linear equations would have infinitely many solutions. Since this was a word problem, that is why we ended in this manner. Otherwise you just have to say that the given system of linear equations has infinitely many solutions. Now let's move on to the next question. It says that two rails represented by the equation. So there are two railway tracks, you could say, and they are represented by this equation. The question is, will the rails cross each other? So if the rails are going to cross each other, it means that they are going to meet at one single point. And if they are going to meet at one single point, at this point, the value of x and y for both the rails would be same. So what we are going to see is, whenever we solve any two linear equations or system of equations, the value that we get for x and y, it is for both the equations. So that is basically the common solution of both the equations. So here we have to see whether these systems would have common solution or not. So again, let us solve these two equations using the substitution method. So consider your equation 1, which is x plus 2y minus 4 equals to 0. Let us write this in the standard format, which is x plus 2y equals to 4. Now isolate the value or isolate the variable x. So x in this case would be 4 minus 2y. Name this as equation star. Now step number 2, use equation number 2. Substitute star in equation 2 we get. So when you substitute star in equation 2, let us first write equation number 2 in the standard format. So I'll send 12 on the other side, and now substitute x as 4 minus 2y. Multiply 2 inside the bracket, so we get 8 minus 4y plus 4y equals to 12. Now just like previous problem, here also the variable terms get cancelled because we have minus 4y plus 4y, and we get 8 equals to 12. Now there is a difference as compared to that of the previous question. In previous question we got 18 equals to 80, which was indeed a true condition, but here if you see, you get 8 equals to 12. Now by any means we know that 8 is never equal to 12. So this is an absurd condition that we get, and this is never possible. If this is never possible, it means that the x and y's in this case in both the equations would not have a common value. Basically, this system of linear equations would have no solution, and if they are having no solution, it means that the rails would not cross each other. That's why we can say that therefore the given system of equations will have no solution as 8 is not equal to 12, and therefore the rails do not cross each other as they do not have common points. So what can we conclude from today's class? That if you get a condition where you have numerical values on both the sides of the equation, and if the condition is true, then you can say that the given system of equations has infinitely many solutions. So you just have to say it has infinitely many solutions. You're not supposed to find specific values for x and y. And if the condition is false, which was the case in the second problem, then the given system of equation has no solutions. So these are the two types of problems where you either get no solution to the given system of equations or infinitely many solutions depending upon the condition that you get. So the agenda for today's class was learning these two special cases, and with this we come to the end of today's class. I hope you have enjoyed and you have also understood both the problems. Thank you so much. See you in the next video.